Perhaps the greatest question facing the human race is to discover where we came from and to find out what is our ultimate fate.
Every culture, every age has asked that question and tried to answer it.
It's one of the greatest adventures of the human mind to find out where we came from, where we are, and of course, in the end, where we're going.
Cosmologists now realize that to understand what the future may hold, they first have to unravel what happened at the beginning of the universe, at the start of time itself. In our daily lives, time is constant and dependable. It's almost impossible for us to imagine, but before the creation of the universe, there was no time.
We can trace back cosmic history to a stage when everything was very dense, very compressed, very hot. But the further we go back, conditions were so extreme that we can't really rely on any of our common sense intuitions. We can say that time, in the sense we understand it, didn't really exist before that.
So when did the clock start ticking? 12 billion years ago, there was absolutely nothing. No matter, no space, no time. We may never know how or why it happened, but a seething mass of energy, smaller than an atom, grew from nothing. You're inside the Big Bang, the birth of our universe, a violent fireball of unimaginable heat. For England's astronomer royal Martin Rees, understanding the Big Bang is the key to the universe.
Something that was literally originally only the size of a single atom or smaller, expanded to be large enough to encompass everything in our present universe.
Only the minutest fraction of a second had passed. But all of this was puny compared to what was about to happen. Propelled by a new surge of internal energy, the universe suddenly entered an incredible period of inflation. It expanded 100 trillion times to the size of a grapefruit. Einstein's famous equation, E equals mc squared, told us that energy and mass were interchangeable. It gave us the knowledge to build weapons of mass destruction and the knowledge to understand how our universe was born. When a nuclear bomb explodes, a tiny amount of matter is completely annihilated and converted into energy. But in the Big Bang, the exact opposite happened. Pure energy was converted into matter. Approaching a millionth of a second old, the universe was brimming with energy, so intense that it was spontaneously converted into lumps of matter, and its arch-rival, antimatter. A titanic battle ensued. Subatomic particles annihilated each other, blow for blow, particle for particle. When matter and antimatter meet, they mutually destruct. This is the most powerful release of energy known.
If our universe started off with equal amounts of matter and antimatter, all the atoms would annihilate with antiatoms, and we'd end up with a universe consisting just of heat and radiation, but nothing from which we and the stars could have been made.
But somewhere in this tiny blazing inferno, the process was slightly imperfect. there was more matter than antimatter. At the end of the battle, matter had won, and the universe was far from empty. Every time a particle of antimatter had been annihilated, the energy was converted into radiation. And that radiation is right before our very eyes. Don't adjust your set. Hidden in the interference on a badly tuned TV set is the energy signal left from the first second of the universe.